on the collection of the electronic evidences. So the electronic evidences, such as, first, when you are collecting the electronic evidences, first you need to list all the systems which are involved in the incident, their order of volatility. Try to gather those evidence which are more volatile, okay, and then the system clock drift, the timings, okay. Collect the evidence from the people who are part of the incident, okay. Capture the electronic serial numbers of the drive and other user accessible data. Write protected and virus check. Do the virus check and the write protected of the drives. Check the integrity of the media as well. So electronic evidence consists of the data file, okay, the office desktop computer, workstation, notebook, home computer, palm top, network file servers, backup tapes, disaster recovery backup tapes, okay, other media such as tape archived, floppy disk, portable media, and etc. So there are some guidelines for acquiring the evidences. Sample banners are used to record the system activities when used by unauthorized users. Okay. If in warning banners, organizations give clearly unequal notice to the intruders by signing up to the system. So banners means when you are trying to access someone's account and you are invalid, so you get a pop-up saying that you are an invalid user. So you must check for those logs also. Okay. The equipment is seized when the connected to the case. Okay. At the time of seizing process, the computer should be powered down. Okay. So if you find a computer at a crime scene which is in a powered on state, in that case you need to remove the power source and the plug from the power source directly. Okay. You should not shut it down. Okay, and if you find the computer at the crime scene with the black screen on the monitor, but you see the computer is live, so what you have to do is you have to move the mouse. Okay, don't press any keys, because by pressing any keys you might close some file or you might change some logs as well. Okay, so ensure that the examiner storage device is forensically clean. Now here, forensically clean means, let's say let's imagine that I am a forensics investigator, let's take it as, and I have examined a case in which I have used a drive as to take the backup of the evidences, or to take the evidences from the captured hard disk from the crime scene. Okay, and after solving that case, I have to use that drive again. Drive which is my personal drive or the organizational drive where I am keeping the evidences. So I have to clean that drive forensically clean. That means I have to clear all the data from there. Okay, I have to convert the zeros into ones, so that if I will use it again and in another case at the time of recovery, the data of older case doesn't come up. Okay. Write protection should be initiated if available to preserve and protect the original evidences. Next is the secure the evidence. Now, secure the evidence without damaging the evidence integrity. So you have to secure the evidence in the correct place. Okay, you have to maintain the chain of custody, identify the digital and non-digital artifacts, maintain a log book at the entrance of the lab to log the timings and name of the person visited. Okay. Place an intrusion alarm system in the entrance of the forensics lab. Contact the law enforcement agencies to know how to preserve the evidences. Now there is something called evidence management, how you will manage the evidences. So there are 4 major points in evidence management. That is the protection, the documentation, evidence transfer, and the procedures. So evidence management helps you in protecting the true temperament of the evidence. Okay, it helps you in protecting the evidence without tampering it. Okay, documentation, this is the archive of properly handling and documentation of the evidence. From the time of capturing the evidence till the solving, everything needs to be documented. So in this part you write everything about that evidence. Evidence transfer. So at the time of transfer, both sender and receiver need to give the information about date and time of the transfer and the chain of custody record. So you need to maintain the chain of custody record of the documents which you have captured from the crime scene and sending to the laboratory. Procedures are used to protect the evidence and document while collecting and shipping, such as the log of the project, the tag uniquely identify the evidence. Whenever you capture evidence from the crime scene, you put a unique tag on each of the evidence so that it can be identified uniquely. Okay, and a chain of custody records. So chain of custody, what is chain of custody? So chain of custody is, as I've discussed earlier also, is a legal document that demonstrates the progression of the evidence as it travels from original evidence location to the forensics laboratory. So whenever you capture evidence from the crime scene and you send it to the forensic lab, so till then whatever happens to whom it has been handed over, everything is written in that document. So a chain of custody form should identify as a sample collector, sample description, type and number, the sampling date and location, any custodian of the sample. This is a kind of this is a sample chain of custody form, okay, in which you have the case number, the reference, the model, serials, everything needs to be written. Here there is something called date, name and client, okay, signatures and the reason. Next is acquire the data. Now once you have acquired the evidence, you need to acquire the data from there. Original evidences should never be used for analysis. Never work on the original evidences. Always make a copy of those evidences. So duplicate the data. That is called imaging. So duplicate the data to preserve the original data. You have to work on the image file of the data. Okay, as we have discussed in the earlier module also. So the data should be duplicated bit by bit stream copies. Okay. So the data can be duplicated either by hardware or software. It depends. If as a forensic investigator you have hardware devices with you, so you can take the image at the crime scene itself, or otherwise you can bring it to the laboratory and using some kind of software or that particular hardware as well, you can take the image. Okay, the duplicate data is sent to the forensics lab for further analysis. Verify image integrity. So image integrity, for maintaining the image integrity, you can calculate the MD5 hash. So some hashes value shows the image as the same as the evidence. Okay. So tools used for calculating the hash value: hashcalc, MD5 calculator, hashmapfiles, MD5 sum. Okay. There are some other tools available. So this is a sample. So we will be doing this tool in the practical modules when we will be taking the image and doing the duplication. Recover lost or deleted data. So you have to recover the deleted files. So first take the image and use some softwares available to recover the data, like Recover-My-File, Digital Rescue Premium, ESUS. There is something called Stellar Phoenix Windows Recovery. That's a good one. There is a free open source tool that is called Test Disk that can be used. Okay, so in this module we will see how to calculate hash value, okay, of any evidence, okay, basically to create a checksum so that we can maintain the integrity. So to be an expert computer forensics expert investigator, you must have sound knowledge of the tools, okay, used to compute hashes and check the checksums. Okay, so we will use a tool called hashcalc, basically hash calculator if you call. So hashcalc allows you to compute messages, message digest MD5, okay, and checksums, HMAX for files, even text and strings. Okay. So it offers you a choice of 13 of the most popular hash and checksum algorithms for calculation. So I'm going to install the Hashcalc. So I'm going to launch. I don't want to read the readme file. So this is the hash calculator. Okay. So now I'm going to calculate a hash for a file. Okay, you can calculate for a file, you can calculate for a text string, or you can calculate for a hexa string also. So I'm going to calculate for a file. Okay. So here are the hashes that can be used. So I'm going to locate the file which I want to calculate the hash. So it's in my desktop. I have some images, okay, as an evidences. So I'm going to take one of the images. So here's the hash calculator. So I'm going to select as BlackBerry. Okay. Now what hash I want to calculate? Okay. MD5 or MD4 SHA-1. Okay. RIPE MD160 CRC is. So you select any of the hashes you want to calculate and simply click on the calculator. So it will calculate all the hashes for you. Like this is for MD5, so MD4 is SHA-1. Okay, so to calculate HMAC for a data, like that's called CADE hash message authentication code for a data, you can simply check the HMAC checkbox. Okay, and in the key format in the key format box, simply type a keyword that you want to calculate for. Okay, simply texting. So I'm going to select here as test. So I'm going to calculate a HMAC for test and select the hash function you want to calculate and click calculate. So this is the hash for this test as my key string. Okay. So both windows contains so if you want to perform a calculation for a text string, you can simply select the text string. Simply go here and select the text string. Like I want to type hello John, how are you? Okay, and I'm deselecting HMAC and click on calculate. So hash values will be displayed for the selected algorithm in this window. So this is how you can calculate hashes, checksums to maintain the integrity of the evidences. Okay, using the hash calculator. Okay, so in this practical we will see how to calculate hash and checksum of a file and process. Okay, so checksum and hashes are very important in case of evidences as to create to maintain the integrity of the evidences. So I have a file here, test raw image.dd. It's a dd file. So I will use this as evidence. So we'll calculate the hash value of this evidence. So for calculating that evidence, we will for calculating the hash, we will use a tool called hash my files. Okay, so I'm going to run hash my files. Okay, so this is HashMap file. First here is add files. So first I'm going to use a simple file, that is readme file. It's a text file. So first let's see what's inside this file. So it's the details of HashMap files, version and different version info. So similarly you can calculate hash of any of the file for which you want to calculate. I'm going to add. So here it calculates the MD5, okay, and SHA-1 and CRC32 hashes. It also tells you the full path file, date and time, creation, size, okay, extension and attribute. Similarly you can add a process file also. Let's take iTunes. So all the process files of iTunes is added, along with their hashes is also calculated. So again, copy the selected items, and again I can copy their MD5 hashes. Similarly I can add a folder, I can add some different files. Okay, so I will clear all. So now I'm going to add a folder. So now I'm going to the desktop. Okay, on desktop we have HashMap files folder. Okay, so it's calculated all the files of that folder. Let's taken the files of that folder and calculated the hash of those files. Okay, so these are the way you can calculate the hashes using HashMap files. Okay, that's it. Thank you.